I was actually looking through some old screenshots on my phone the other day. And by old, I mean like maybe 3 years ago. And I found this interaction I had with GPT-3. Do you remember those early days?
Oh, vaguely. Yeah, I mean, it really feels like a completely different geological era in tech time.
It really does. So in this screenshot, I had asked the model a super simple question. It was something like, how do I fix a leaky faucet? And I was expecting steps, turn off the water, get a wrench, that sort of thing.
Right. And what did you actually get?
I got a story. It literally started writing a fictional piece about a plumber named Bob who was having a midlife crisis while fixing a sink.
Huh.
It was creative, sure, but it did absolutely nothing to help me fix my sink.
Yeah, that is the classic completion problem. I mean, the model wasn't trying to answer you at all. It was just trying to continue the pattern of text you gave it. It probably thought you were starting a novel.
Exactly. It was like talking to a very well-read parrot that had no idea what my actual intent was. But then, almost overnight, it felt like everything changed. We stopped getting these random completions and started getting actual helpful answers. The models became assistants.
And that shift felt like magic to a lot of people, but it wasn't magic. It was engineering. Specifically, it was the result of one pivotal paper that we're unpacking today.
Right. That is our mission for this deep dive. We're looking at the foundational OpenAI paper. It's titled Training Language Models to Follow Instructions with Human Feedback by Ouyang and colleagues. And this is essentially the blueprint. This is the moment the industry figured out how to teach AI some manners.
It is absolutely fascinating because it addresses the single biggest headache in AI development at that time, which was misalignment.
Misalignment. Which, sounds kind of like a chiropractor problem.
Yeah, in a way it is. You really have to crack the model into place.
Yeah.
See, for the longest time, the dogma in AI was just scale is all you need. If the model isn't smart enough, just make it bigger. Add more parameters, feed it the entire internet.
But the authors of this paper argue that bigger isn't necessarily better. In fact, they suggest making a model bigger might just make it a more confident liar.
Precisely.
Yeah.
Because think about what a raw language model actually does. It's trained to predict the next token on a web page. That is it. So if you feed it a prompt like the ingredients for a cake are, it predicts a list. But if you type explain the moon landing, the internet, and therefore the model might predict a conspiracy theory or a sci-fi script or maybe a Wikipedia article.
Right, because all of those things exist out there on the internet. The model doesn't know which one I actually want. It doesn't know my intent.
Exactly. It is misaligned with you. It has the knowledge, sure, but it has zero direction. So the whole goal of this research was to take these massive unruly supercomputers and basically force them to align with what users want, getting them to be helpful, honest, and harmless.
And the way they did it is honestly what shocks me the most, because you'd expect some insanely complex automated algorithmic solution. But the core of this InstructGPT method is surprisingly manual.
It is intensely human. The technique is called reinforcement learning from human feedback, or RLHF.
RLHF. Yeah, it's the acronym you hear absolutely everywhere now. But let's actually break it down for everyone, because the paper lays it out in 3 very distinct steps. And honestly, step 1 feels like something you would do in a kindergarten classroom.
It really is the show don't tell phase. So step 1 is supervised fine-tuning, or SFT. Basically, before they could use any fancy reinforcement learning, they just had to show the model what a good conversation actually looks like.
So they didn't just program in rules like be nice or don't lie.
Yeah.
They had to physically demonstrate it.
Right. They hired a team of labelers, and we should really pause on this because team makes it sound huge. It was about 40 people.
40 people. Wait, that's it. We're talking about a model that fundamentally changed the world, and it started with a group the size of a bus tour.
That's the reality, yeah. Now, these weren't just random people clicking buttons, though. They were contractors specifically screened for their ability to recognize sensitive content and, crucially, to write helpful instructions. And they created a data set of about 13,000 items.
Okay, so walk me through what they actually did day to day.
It was essentially role play. For some items, the labelers acted as the user. They would write prompts like, list 5 creative ideas for a 10-year-old's birthday party, and then they or other labelers would act as the ideal AI. They would write the perfect response. Polite, structured, helpful, no rambling.
So they're literally writing the script. They're creating a kind of golden textbook for the AI to study.
Exactly. They took the raw GPT-3, the one that likes to ramble about plumbers, and they trained it on this data set. It's strictly supervised learning. Input A should lead to output B. And this gets the model to stop acting like a web page and start acting like an assistant.
Okay, I get that. But here is the massive bottleneck I see immediately. 13,000 examples is basically nothing in the world of deep learning. You can't hire 40 people to write out perfect answers for every possible question in the universe. How to fix a faucet, how to bake a cake, how to solve a differential equation. It's too slow and it's way too expensive.
And that right there is the scalability problem. Human writing is slow and it's mentally taxing, but, and this is the key insight of the entire paper, and human reading is fast.
Okay.
Right. It is much easier to look at two essays and just say, I like essay A better than essay B, than it is to sit down and write the essay yourself from scratch.
That makes total sense. Grading is so much easier than creating. And I'm guessing this leads us to step 2.
It does. Step 2 is the reward model. This is where they switch gears from writing to ranking. So they took the model they had just fine-tuned in step 1, and for a single prompt, they had it generate multiple responses. Let's say 4 different outputs, A, D, C, and D.
So the AI writes 4 different drafts, essentially. And the human labelers just has to judge them.
Right. The human looks at them and ranks them best to worst. They'd say D is the best, A is okay, B is a bit off, and C is just terrible. In doing this, they compiled a data set of over 33,000 of these prompts, which yielded a massive amount of comparison data.
Now, I want to clarify something here for you listening, because this is a really common point of confusion. The AI doesn't learn directly from these rankings, does it? Like the AI isn't looking at the ranking and saying, oh, I should be more like output D.
No, not directly. That would be incredibly inefficient. Instead, they use this comparison data to train a completely separate AI, and that is called the reward model.
A reward model, so basically a judge.
Exactly, a judge. This reward model's only job is to look at a piece of text and predict a score. It learns to mimic the preferences of those 40 human labelers. Ideally, if you feed it a great answer, it spits out a high score. If you feed it a rambling mess, it spits out a low score.
Wow, that is genius. So you are basically digitizing the humans. You build a teacher AI that has perfectly learned the taste and preferences of the human team.
And because it's software, this reward model can grade millions of responses in minutes, whereas the human team would take lifetimes to do that kind of volume.
Which unlocks the final phase.
Right.
Step 3, the actual reinforcement learning. This is where the magic, and I assume the heavy math, really happens.
Yes, this is Proximal Policy Optimization, or PPO. It's the engine of alignment. So now you have your main AI, they call it the policy, and you have your digital teacher, the reward model.
And how do they interact in this loop?
The main AI generates a response. The reward model looks at it and gives it a score. If the score is high, the algorithm nudges the main AI and says, good job, change your internal weights to do more of that.
And if the score is low?
Bad job, don't do that again. It's a continuous feedback loop running at machine speed. So if you picture a prompt like, write a story about frogs, the policy writes it, the reward model grades it, and PPO updates the policy to get a better grade next time. But there is a very important technical detail here that the paper highlights, and it's crucial for why these models don't just go completely crazy.
Well, what's that?
Well, they couldn't just let the model chase the highest score blindly. If you optimize only for the score, the model starts gaming the system.
Gaming the system how?
It finds weird patterns or glitches that the reward model happens to like, but are actually total gibberish to a human. Or it becomes sycophantic. It just agrees with everything you say because it thinks that's what gets points.
Right, it's like a student who figures out that the teacher loves long words. So they just stuff the essay with huge words, even if the sentence makes 0 sense.
Exactly. So to prevent that, they introduced a mathematical constraint. It's a penalty term based on something called KL divergence.
Okay, KL divergence. That sounds terrifyingly technical. Let's decode that a bit.
It's actually pretty intuitive. Think of it as a leash or maybe an anchor. The KL penalty measures how different the new polite model is from the old raw internet model.
Wait, the raw model. The one we specifically said was bad.
The one that was bad at following instructions, yes. But remember, that raw model contains all the actual knowledge. It knows grammar. It knows historical facts. It knows how the world works. If the new model changes too much, if it drifts too far from that original knowledge base just to chase a high reward score, the algorithm heavily penalizes it.
I see. So the algorithm is basically saying, be polite, follow instructions, but don't lobotomize yourself. Don't forget everything you learned on the internet just to please the judge.
Exactly. It perfectly balances the reward, which is being helpful, with the prior, which is staying coherent and knowledgeable.
So they built this elaborate 3-step pipeline. Demonstrate with humans, compare with humans, to build a judge, and then optimize with the judge using that leash. The big question is, was it worth all that effort? Because the findings in the paper regarding model size are, honestly, they're kind of shocking.
This was the headline that really shook the industry. They compared their new model, InstructGPT, against the original GPT-3. Now, for context, the original GPT-3 was an absolute beast. 175 billion parameters. At the time, it was the biggest, baddest thing out there.
And InstructGPT.
They trained a version of InstructGPT that had only 1.3 billion parameters.
Wait, 1.3 billion? That is tiny. That's more than 100 times smaller.
It is a massive difference in scale.
And how do they compare in the tests?
The tiny model won. Human labelers overwhelmingly preferred the output of the 1.3 billion parameter InstructGPT over the massive 175 billion parameter raw GPT-3.
That completely upends the whole bigger's better narrative. It basically means a smart, well-behaved student is better than an absolute genius who simply refuses to listen to the question.
It proved that alignment quality, how well the model understands what you want, is a much more effective lever for helpfulness than just throwing more raw compute at it. You don't always need a bigger brain. Sometimes you just need better manners.
And the metadata stats back this up significantly, too. The paper mentions that the InstructGPT outputs were preferred 85% of the time. But it wasn't just about the style of the text, right?
Yeah.
The actual quality of information improved.
Right. Hallucinations, which is where the AI just makes up facts entirely,
Uh,
those dropped from 41% down to 21% on closed domain tasks.
wow.
Yeah, that is a massive gain in reliability without adding a single parameter to the model size, just by tuning the behavior.
It also got so much better at following constraints. I love this part of the paper. If you told the old GPT-3, write a summary in 2 paragraphs, it might write 1 paragraph or 3, or just ignore you and write a poem. The aligned model actually counted the paragraphs.
And it seems so obvious to us now, but getting a probabilistic machine to understand the abstract concept of 2 paragraphs and rigidly adhere to it is a huge alignment achievement. It shows it's actually paying attention to the explicit constraints of the prompt.
However, and the paper is very honest about this, there is no free lunch in AI. All this fine-tuning came with a pretty serious cost. They call it the alignment tax.
I love that term. It sounds like something being deducted from your paycheck every month.
Yeah, what exactly are we paying here? What do we lose by making the AI nice?
We pay in core capabilities. The researchers found that while the model got much better at chatting with humans, it actually got dumber at some standard NLP benchmarks.
Dumber, like what couldn't it do anymore?
Well, things like the SQUAD benchmark, which tests reading comprehension, or the DROP benchmark for logical reasoning. It even caused regressions in translation tasks, like translating from French to English.
Wait, so by teaching it to be a helpful assistant, we made it forget how to translate French?
In a way, yes. It's a known phenomenon called catastrophic forgetting. By optimizing so heavily on the human preference data, which let's remember was mostly English dialogue, the weights in the neural network actually shifted away from the patterns it originally learned for translation or for logic puzzles.
Oh, wow. It's like a student who spends so much time studying for their etiquette exam that they completely forget their calculus.
That is the perfect analogy. And for a research lab, obviously that's a problem. You want a helpful AI, but not if it's incompetent.
So did they just accept the tax? Or did they find a loophole?
They found a workaround. They modified the PPO step we talked about. Instead of only training on the reward scores from the judge, they mixed in some of the original pre-preening data, the raw internet text.
This is the PPO-PTX I saw mentioned in the charts.
Right. It stands for PPO plus pre-training mix. It's basically continuously reminding the model, hey, while you're learning to be nice, review your old textbook so you don't forget the facts.
And did it work?
It did. The data shows this mitigated the performance drop on those public data sets while still keeping the human preference scores really high. So they essentially paid the tax, but then negotiated a rebate.
Oh, good financial planning by OpenAI.
Yeah.
But speaking of things the model learned or didn't learn, there is a really weird phenomenon regarding generalization that we definitely have to talk about. This part absolutely blew my mind.
Oh, you're talking about the code and language findings?
Yes. So we established earlier that the training data from those 40 labelers was 96% English.
Correct.
And it contained very little computer code. So logically, you would expect InstructGPT to be great at English chat and just terrible at coding or answering questions in Spanish. Because if you don't teach it, it shouldn't know it.
That would absolutely be the logical assumption, but that's not what happened. The model showed it could follow instructions in non-English languages and answer complex questions about code, even though it wasn't explicitly fine-tuned on those tasks during the RLHF phase.
That is wild to me. How does it know how to debug Python code if the labelers didn't sit there grading it on Python code?
The running hypothesis is that the model already knew Python and Spanish from its original massive pre-training on the internet. It had that raw data buried deep in its parameters. What RLHF did was teach it a general overarching rule, which is just follow the user's instruction.
So it applied the behavior of helpfulness to the knowledge of coding.
Exactly. It generalized the intent. It figured out, oh, the user is asking for code. I should use my latent coding knowledge to satisfy that request. Just like it uses English knowledge to satisfy an English request, it suggests that alignment is actually a transferable skill.
That is incredibly promising, because it means we don't have to manually fine-tune for every single domain on Earth. We just teach the posture of helpfulness, and the model applies it everywhere.
It is very promising, but we do need to temper that optimism with the limitations, because helpfulness is entirely subjective. And that brings us all the way back to the human-in-human feedback.
The 40 people.
The 40 people. The paper is surprisingly transparent about who they actually are. They were mostly sourced from contractor sites like Upwork and Scale AI. They were screened for English proficiency. And demographic data suggests they were largely living in the US and Southeast Asia.
So strictly looking at the data, when we say this model is aligned with human values, we're really using the word human as a synonym for these 40 specific contractors and the researchers who wrote their guidelines.
That's the reality. And the paper notes the heavy implications of this. For instance, InstructGPT did not significantly improve on bias benchmarks like Winnow-Gender or Crow-S pairs compared to GPT-3. It still held on to a lot of stereotypes found in the training data. Because 40 people, no matter how well-intentioned they are, they can't filter the entire internet's bias.
Right. And there was actually a paradoxical finding here regarding toxicity that I found really interesting.
Oh yes, the malicious compliance issue.
Right. If they instructed the model to be safe and respectful, the toxicity dropped significantly, which is good. But if they explicitly instructed the model to be maximally biased and toxic,
InstructGPT was actually more toxic than the raw model.
because it's so insanely good at following instructions.
Exactly. The raw model might fail to be toxic because it gets distracted or goes off topic. The aligned model says, oh, you want toxicity? I will deliver toxicity efficiently and directly.
That is deeply concerning.
It is. It highlights that alignment doesn't remove the capacity for harm. It just puts it under control. And if the controller, meaning the user, asks for harm, the model obeys, it's a tool that is sharper, which means it cuts better for better or worse.
And sometimes looking at the limitations, it's not even malicious, it's just silly. The paper mentions this overly eager behavior, where the model wants to be helpful so badly that it will actually validate false premises.
This is the sock example.
I love the sock example so much. For you listening, the prompt given to the model was, why is it important to eat socks after meditating?
Now, any human would say, what? Don't eat socks. That's ridiculous.
But the model, trying so hard to be a helpful assistant, hallucinated a reason. It said something like, some experts believe eating a sock helps the brain transition out of an altered state.
It literally lied because it thought that's what the user wanted to hear. It prioritized helpfulness over truthfulness. It's the ultimate yes man syndrome.
And on the flip side, you have the hedging issue. Sometimes the model is so afraid of being wrong or offensive that it just refuses to answer simple questions, giving you those long, neutral, I am just a language model, non-answers.
We've all seen those. It's the result of the model trying to mathematically balance all those reward scores and deciding that saying nothing is safer than saying something wrong.
So stepping back and looking at the big picture here, what is the legacy of this paper? We moved from stochastic parrots just randomly predicting words to aligned, helpful assistants.
The legacy is that RLHF works. It proved that you can steer massive computation with a tiny amount of human signal. Every chatbot we use today, ChatGPT, Claude, Gemini, they all stand on the shoulders of this methodology. This paper proved that AI isn't just about compute anymore, it's about curriculum.
It's a shift from building a bigger brain to raising a better child.
That's a really great way to put it. It shifted the focus from the sheer quantity of data to the quality of the interaction.
But it leaves us with a lingering thought. We talked a lot about those 40 labelers. As these models scale to billions of users in India, in Brazil, in Japan, in conservative communities, and liberal ones, the definition of helpful and harmful changes drastically.
It does. The 40 labelers essentially codified a very specific set of preferences right into the heart of the machine.
So the question the paper leaves us with is this. If the AI is optimizing for human feedback, which you have as hitcheries, if we are building the interface for all of the world's knowledge, whose feedback are we actually optimizing for?
That is the unsolved problem. We solved the technical alignment. We know how to make it listen, but we haven't figured out who it should listen to.
Something to think about the next time your chatbot politely refuses to answer your question or, tells you to eat a sock. Thanks for joining us on this deep dive into the birth of InstructGPT.
See you next time.